Imagine, just for a moment, living in a world where questioning the simple mechanics of the sky, I mean, even suggesting that the Earth moves, could lead to, well, not just ridicule, but lifelong house arrest.
It's almost impossible to picture.
Yeah.
And that was the reality, the dangerous reality facing Galileo Galilei.
Right.
Our sources for this deep dive give us this stunning look into his life. He's called the father of modern science for a reason. And we're not just looking at his discoveries, but at the really brutal conflict that happened when his observations directly contradicted dogma.
Dogma that had ruled for, what, almost 2,000 years?
Exactly.
Okay, so let's unpack this. Here's a man armed with basically his own curiosity and a piece of glass he built himself. And with that, he challenges the entire structure of the universe as understood by the most powerful institutions of his time.
Mm-hmm.
So I think our mission today is pretty clear. We need to pull out the specific nuggets of truth he found, yes, but more importantly, we have to understand how he fundamentally changed the rules, how he taught us that observation.
Mm-hmm.
It just trumps authority.
It absolutely does. We're tracing the path of a rebel mind, someone who was, essentially programmed from childhood to demand proof, not just accept what he was told.
And that's really where the story begins.
It is, that radical mindset.
So that mindset, it starts literally from the beginning. Galileo was born in Pisa in 1564, and his father, Vincenzo Galilei, was a famous musician.
A very well-respected musician, yeah.
Mm-hmm.
But one who was known for questioning the established theories in music. He encouraged his kids to test things, to measure them.
So it was this environment of don't just believe it, prove it.
That's it. That idea that you had to test and quantify everything became Galileo's foundational approach to, to everything. He was set up to be a thinker who needed empirical proof.
What's great is that this curiosity wasn't just in a lab somewhere. It happened everywhere. We have that classic, fantastic story of young Galileo supposedly sitting in the Cathedral of Pisa.
Right. He wasn't focused on the sermon at all.
No. He was watching a large bronze lamp suspended by a chain, just swinging back and forth.
And he noticed the rhythm. The swings were perfectly rhythmic. But what's fascinating is, he didn't have a stopwatch. They didn't exist.
So what did he use?
He used his own pulse. He timed the swings with his heartbeat and realized the time for each swing was the same, no matter how big or small the arc was.
That simple observation, I mean, that's incredible. That leads to his discovery of the law of the pendulum, that the time it takes depends only on the length of the string.
He basically invented a core piece of physics just by watching a lamp. It's an amazing story.
And it wasn't just, idle curiosity.
No, it was applied observation. He was initially sent to the University of Pisa to study medicine. That was the lucrative career path.
Mm-hmm.
But he was just captivated by mathematics and mechanics. He spent more time on his own experiments than in his lectures. And, he eventually dropped out.
I can imagine his father wasn't too happy about that at first.
Probably not. But he found his calling. And he became a professor of mathematics at Pisa when he was only 25.
Okay, so he's a professor. But if he's teaching math, how did he stand out? Everyone else was teaching the same old curriculum.
Well, the crucial detail is how he taught. Academic life back then was just total adherence to Aristotle. If Aristotle said something was true 2,000 years ago,
then it was true today. End of story.
End of story. But Galileo refused to just read from dusty old texts. He revolutionized the classroom. He taught by experimenting, by proving things right there in front of his students.
He was the one brave enough to stand up and say, Aristotle is wrong, and let me show you why.
Exactly. And that willingness to publicly contradict established wisdom leads us right into his early challenges, where he starts proving the power of observation.
Right. This is where it goes from a theoretical challenge to a physical one.
And nothing illustrates this better than his most famous experiment at the Leaning Tower of Pisa.
A story everyone knows, but the context is so important. For 2 millennia, the entire educated world just accepted Aristotle's idea that heavier objects fall faster.
It seemed logical, right? But it was completely untested.
So Galileo picks the tower because it's so visible, there's no special equipment needed, it's just a public demonstration.
He climbs the tower with 2 metal balls. One's large and heavy, the other is small and light. And he's basically asking everyone watching to trust their own eyes over 2,000 years of intellectual authority.
He must have known what they were all expecting to see.
Oh, absolutely. He made it a public spectacle. He drops them at the same time, and the sound of those 2 balls hitting the pavement at the exact same moment was, it was the sound of 2,000 years of physics shattering.
Wow, just like that.
He used measurement and observation to completely overturn pure theory.
And that one simple action, just watching two metal balls fall, it cements his reputation. He's both a genius and a troublemaker.
A relentless troublemaker, yeah. Because he physically proved that theory has to yield to observation. It completely changed the starting point of physics.
And this demand for tangible proof meant he wasn't just some philosophical disruptor, he was also a very practical inventor.
Intensely practical. He wasn't just asking why. He was asking, okay, how can this be used?
So what are some examples?
Well, look at his inventions. Before the modern thermometer, he creates the thermoscope, a simple device using water and air to show temperature changes. He made heat measurable for the first time.
Okay.
He also developed these sophisticated military compasses, tools for soldiers to aim cannons accurately, and even for merchants to calculate complex taxes.
So his work had immediate, functional, real-world applications.
Absolutely. And this whole focus on measurement and applied science, it was all just preparation for his ultimate act of defiance, pointing that same experimental eye toward the heavens.
Which brings us to 1609 and the telescope.
Revolution, yeah.
So this is where the story just gets so compelling. Galileo hears these rumors about a strange Dutch device that makes things appear closer, a spyglass.
Right, but he doesn't have a blueprint. He hasn't even seen one.
Nothing to copy.
Nothing. But based on just the rumors and his own mastery of optics, he figures out the principle behind it, the arrangement of the lenses. And within 24 hours, he builds his first prototype.
In 24 hours, that's unbelievable.
And he just keeps refining it. He gets it up to a magnification power of 30 times, making it the most powerful telescope in the world. And then, instead of just selling them to navies to spot ships.
He does the unthinkable. He points it at the night sky.
And what he saw it completely destroyed the framework on the cosmos. For centuries, the model was geocentric. Earth was the absolute fixed center of creation.
And everything, the sun, the moon, the planets, they all orbited us perfectly.
Exactly. And that model was upheld by, well, both scripture and the authority of the ancient astronomer Ptolemy. It dictated that the heavens were flawless, perfect, unchanging.
So what was the first thing Galileo saw that just shattered that idea of perfection?
The moon. First, he looks at the moon. It was supposed to be a flawless, smooth sphere of some pure celestial substance.
Yeah.
But he sees mountains. He sees craters. He sees deep shadows that he correctly calculates are cast by mountains taller than any on Earth.
So the moon looked just like our world, flawed.
Exactly like our world. And that immediately contradicted the teaching that heavenly bodies were perfect. And that was the first direct challenge.
Okay, so that's a huge crack in the foundation right there. What was the second big observation?
The second was maybe the most system-destroying of them all. Jupiter has moons.
Wow.
He observed 4 tiny points of light near Jupiter. At first, he thought they were just stars. But he keeps watching night after night, and he sees them shifting their position in orbit around Jupiter.
So, not everything orbits the Earth.
Not everything revolves around the Earth. That single discovery proved it. Some things very clearly revolve around other planets.
The entire philosophical structure just collapses with that one observation.
It does. Because the old geocentric model needed all these, frankly, unbelievable mechanisms like epicycles and strange loops to explain how the planets moved. Galileo's observation of Jupiter's moons offered a much simpler, undeniable explanation.
The sun-centered model.
The heliocentric model. It suddenly became much more plausible, simpler.
Oh, and simplicity often reveals the truth in science. What was the third visual proof he found?
The third was definitive proof about light in motion. Venus has phases, just like our moon.
What does that mean exactly?
You tracked Venus and saw it go through a full cycle crescent, gibbous, full. And that is physically impossible if Venus orbits the Earth. It only makes sense if Venus is orbiting the sun.
That's the visual nail in the coffin. You can't really argue with what you can literally see through the lens.
Right. And finally, his telescope revealed countless stars that were invisible to the naked eye. He points it at the Milky Way, and it's not a haze, it's millions of individual stars.
Showing the universe was just far, far bigger than anyone had ever imagined.
Bigger and more complex.
So if you put those 4 discoveries together, the imperfect moon, Jupiter's moons, the phases of Venus, and a massive universe, it led Galileo to one inescapable conclusion.
The sun, not the Earth, is the center of the universe.
And this is where the conflict erupts.
This is where it goes from a scientific dispute to theological and political warfare. If the Earth wasn't the center, then the literal interpretation of certain scriptures was flawed. And by extension, The authority of the church, which had upheld this view for centuries, was threatened.
I just can't imagine the pressure. The church held immense power, and their teachings were considered absolute truth. So questioning the Earth's position wasn't just being wrong, it was heresy.
Dangerous heresy. And Galileo.
Mm-hmm.
You know, for all his brilliance, he was also prone to arrogance. He was an outspoken character.
A scientist, not a diplomat.
Not at all. He published his discoveries in books, like Dialogue concerning the two chief world systems, where he openly and often mockingly ridiculed his critics. He didn't want compromise, he wanted victory.
And that approach, unfortunately, just escalated everything. He was warned repeatedly, and then eventually he was summoned to stand trial before the Roman Inquisition,
where he was facing the very real threat of execution. Despite having overwhelming, measurable, undeniable scientific evidence, he was forced to publicly deny his own discoveries.
to swear that he abjured, cursed, and detested the sun-centered model.
I mean, can you imagine the psychological weight of that?
Yeah.
Knowing you hold an undeniable truth about the cosmos, but having to choose between that truth and your own life.
The consequence was lifelong house arrest, silenced, confined to his villa.
But his defiance led to one of the most powerful legends in scientific history. As he rose from his knees after that forced denial, the story goes he whispered under his breath, "Et pour si mouave."
And yet it moves.
And yet it moves, meaning the Earth still moved around the sun, regardless of what they forced him to say.
That phrase just captures his entire legacy, doesn't it? A commitment to truth above all else.
It does. And he spent his last years under house arrest, going nearly blind, but he never stopped working. During this period, he wrote 2 new sciences, which laid the foundation for modern mechanics. Many considered his greatest scientific work.
He died in 1642, still a prisoner in his own home, but there's this beautiful, almost poetic symmetry in that date.
Yes, Galileo died in the very same year that Isaac Newton was born.
Wow.
And Newton, who would go on to describe the laws of motion and gravity that Galileo's work made possible, later paid tribute to him.
He famously said, "If I have seen further, it is by standing on the shoulders of giants." Galileo was, without a doubt, that giant.
Today, we remember him with titles that reflect the revolution he started: the father of modern science, the founder of experimental physics, the rebel who demanded proof.
So, to summarize this deep dive, it seems Galileo didn't just add new facts to astronomy. He changed how we seek truth. He shifted the priority of knowledge away from tradition and authority and toward proof.
Quantifiable, repeatable observation and proof. Every time you conduct an experiment, every time you trust data over assumption, you are continuing Galileo's revolution.
He taught us that knowledge has to be earned, not just inherited.
And he left us with that single, powerful, defiant thought. Truth doesn't care who believes it. The universe moves, even when we're afraid to look.
Which leaves us with a final question for you to think about in your own field today. What accepted belief, what widely held assumption in your industry, is waiting for its own, and yet it moves, moment?